This video is on compound inequalities. This statement right here is considered a compound inequality because there are two inequalities in one. Right here, this part right here says x is less than 7. But if you just look at this part here, this says x is greater than 3. So at the same time, we want all of the numbers that are greater than 3 and less than 7 at the same time. The numbers on the number line that would fit that criteria are these. The numbers that are between 3 and 7. All of those numbers are greater than 3 and at the same time less than 7. All we need to think about is what are we going to put on the 3 and the 7? Because this statement was originally just plain old less than signs, we would use the parentheses. This is our graph of 3 is less than x and at the same time x is less than 7. Now that's a complicated way to just talk about the fact that where is x located? X is located somewhere between 3 and 7. And where did we shade? Between 3 and 7. That's all you have to do with these compound inequalities is shade between the two numbers. You also have to decide what kind of symbol to put at each number. Because these are both plain old less, you're going to put the parentheses on there. The parentheses do need to face each other. I think of these like bookends. They face each other. And the reason they face each other is if you just look at this part right here, this says x is greater than 3. That's why we are shading that way, and that's why our parenthesis is facing that way. If you just look at this part here, x less than 7, that's coming in this way, shading to the left, and that's why our parenthesis is facing to the left. So the easy way to graph these is just to think about where is the x located. It is located between the 3 and the 7, and that's where you shade. Once you have made the graph, the next thing you're going to have to do is do the interval notation. Well, this is very easy to do the interval notation on because we started at 3 with a parenthesis. We went to 7 with a parenthesis. That is the interval notation that goes with this inequality because this says we would shade from 3 to 7 just like we did on the number line. Another one just like this, all we have to do is put our endpoints of 4 and 6 on here. We will shade between the 4 and the 6, and plain old less means I will use the parentheses right there. This leads directly to my interval notation of 4, 6. Tiny bit different because of the inequality sign here, but it's still a matter of looking at where the x is. The x is between the -2 and the 5. We put them on the number line. It is less than or equal to, and that's why I will put square brackets here, but I will still shade in here. And the whole idea here is any number in that shaded region, if I plug it back in for x, I will have a true statement. Pick any number in here, put it right there. Let's say we put 3 here. -2 is less than or equal to 3. And at the same time, 3 is less than or equal to 5. Interval notation for this, -2 with a bracket, up to 5 with a bracket, and we're finished. Now these last several were very easy to do the graph because the x here in the middle was a plain old x. The next couple problems you're going to see that what we have in the middle here is not a plain old x. It is still a compound inequality, but we need to do some solving. We've got to do the work to get this x alone. Pretend this 3 wasn't even there and that all you were looking at is this statement right here, 2x plus 1 less than or equal to 7. To get the x alone, you would want to subtract 1 from here and from here, and here's the difference. We also have to subtract -1 from this position also. I think about this like 3 separate columns. Here's a column, there's a column, and there's the 7 that's a column. So we are subtracting 1 from all 3 columns. It's no longer that we are subtracting 1 from both sides. We are subtracting 1 from all 3 columns. Draw our line here, do this arithmetic. -3 and -1 is -4. Bring down your inequality sign. The 1's cancel out, giving us 2x. Bring down your inequality sign. Do the arithmetic, gives us 6. Do we have a plain old x here? No, we don't, but we can get a plain old x here very easily by dividing by 2. What are we going to divide by 2? All 3 columns. So divide this column by 2. We divided the middle by 2 because that's what's going to get the x alone. Divide this by 2. And do your arithmetic. -4 divided by 2 is -2. The 2's cancel out. We have x. 6 divided by 2 is 3. And there's our inequality that we can go directly to our number line from -2 to 3, place those on the number line, because this is less than or equal to for both, we will use the square bracket and shade in between. The interval notation goes directly from your graph, so -2, 3, square bracket, and we're ready to move on. Similar problem. Yes, these are facing the other way, but that's okay. We can still solve this. What's important in these compound inequalities is that these two inequality signs are both facing the same way. These are both facing this way. They both could be facing this way. What we would never have is one facing that way and one facing that way. That just doesn't happen. So they both face the same way, and we're going to solve it the same way. We want to get this x alone. So what we'll get the x alone is we subtract 4 from this column, from the right column, and from the left column. Do the arithmetic. 13 minus 4 is 9. Bring down your inequality sign. The 4's cancel. There's our 3x. -2 and -4 is -6. We don't have the x alone yet, but divide by 3 here, here, and here, and do the arithmetic. 9 divided by 3 is 3. Bring down your sign. 3's cancel, we get x. Bring down your sign, -2. What you need to be careful of here is that these signs are greater than signs. You can't just sloppily put the 3 here and the -2 here on the number line. You can't have a -2 to the right of 3. So there's two ways to go from here. You might want to take this inequality and just totally swap it around. And then it looks like the other ones. And then it's easy to go to the number line, -2, 3, plain old less. So we will use the parentheses, color in between. The other way to go is right from here is to realize, oh yeah, my number line, I got to have the negative over here. I got to have the positive over here. I still will use the parentheses. I still will shade between. So you get the same graph. It just depends on how you want to think about it. Now, this region in here, every single point is my solution set. So if I want to check this, I'm going to put something that's in this region, let's say 0, because 0 is such easy arithmetic, and I'm checking, is 13 greater than 3 times 0 plus 4, and is that greater than -2? We'll do the arithmetic. 3 times 0 is 0, plus 4 is 4. So is this a true statement? Is 13 greater than 4, and at the same time, is 4 greater than -2? Yes, it checks, so we have shaded the correct region. A little more work inside here. It's still a matter of we've got to work to get the x, plain old x, in the middle here. So you know when you see a number in front of parentheses, that means you need to distribute. This other stuff stays where it was. So this is -10, less than 6x plus 10. That's distributing. Bring down your less than 16. And now this looks like the last couple we've done. We need to get the x alone. To undo plus 10, we will subtract 10 from all 3 columns. So -10, -10 is -20, less than 6x because our 10's canceled. 16 minus 10 is 6. To get this x alone, divide by 6 in all 3 columns. Reduce your fraction here. It's okay to have a fraction, no big deal. And then 6 divided by 6 is 1. -10 thirds is the same as the mixed number -3 1/3 if you want to think of that way. But it really doesn't matter. You can put -10 thirds here, or you can put -3 1/3. What you will see math lab wise is graphs already drawn, and you would have to put this number between -3 and -4 because that's where -3 1/3 is. Plain old less means I would have to have parentheses, and I will shade between. I forgot to put my 1 right there. Every single number in that shaded region, if I put it back in there for x, will give me a true statement. Yes, some of these have fractions, and you have 2 ways to deal with this fraction. What I think is the easy way to do is, let's get rid of this 5 to start with. Let's add 5 to all 3 columns, because that's just so easy to do, and we haven't dealt with the fraction yet. So -2 plus 5 is 3. Bring down your 1/2 x. The 5's have canceled, and 1 plus 5 is 6. Now, to undo a division by 2, which is what a fraction is, we need to multiply everything by the reciprocal, which is 2. So multiply by 2, multiply by 2, multiply by 2. So this gives me 6. Over here, the 2's cancel out, which is what we wanted to happen, so we could get the x alone. And there's our 12. And then put our 6 here, our 12 here, plain old parentheses, color between, and interval notation, 6, 12. One comment, let me erase this problem and go over a common mistake I've seen with this. When you do this problem and you decide you're going to add 5, it is adding 5 to each column. It is not add 5 here, add 5 here, add 5 here, add 5 here, because what you've done right here is you have added 5 twice to this part. So notice I've been saying add 5 or add whatever to each column. This is a column, this is a column, and this is a column. So I add 5 here, I add 5 here, and I add 5 here.